Hi Harshit. Okay, so we were doing like linked list last question yesterday, and what we're going to start today is stack. Okay, and we'll check how stack works. Okay, and what are the concept behind it, and so where is it exactly used, and then we'll proceed forward with the methods of stack. What are the methods we have, and okay, then we'll solve some couple of problems on it. So okay, so regarding the last question yesterday which we were talking about, so I find like I tried one more recursive approach for that, and yes, we can discuss that too. So that is also one of the way. So let's discuss that part also. Okay, so let me open the code, and let me put a message in the group, and then we are good to go. Okay, so I've dropped the message. Let's come back here. Let me share my screen. Okay, so reversing key nodes at a time. So this was what we were solving. Okay, give me a minute. Let me get my pen also. Then I can demonstrate it exactly. Just a minute. मुस्कान बोला पापा का फोन जल्दी वहाँ ले चार्ज में लगा दो और ये लैपटॉप का तार इसकी डेल वाले में चार्ज में लगा दो डेल वाले में चार्ज में लगा दो। Okay, so okay, so we were discussing the K reverse question last time. Okay, so let's see it again. Now the approach I used just now is like we can use the while loop too in order to do the operation. Okay, so for example, if I want to reverse just the k nodes at a time. Okay, so if I want to just reverse k nodes at a time, so what I can do is so keep our current on the head. Keep our current on the head. For example, let's say that I have this linked list 10, 20, and 30. Okay, so keeping our forward and previous tunnel and current to head. Okay, and what we can do is we can keep the forward to current dot next, which will be 20. So head is here, current is here, and forward is here. Okay, now making the current next to previous, which is basically the null. Okay, and making your previous as current. Now current as forward. So if we have a close look to this one, what it is trying to do here is keeping your current. So current is initially the 10 we are having. Okay, so this is a while loop way to reverse the node. So what we can do, so c equals to 10 over here, which is basically our current. Okay, now you're saying that forward becomes 20 here, forward becomes 20 here. Okay, so forward equals to current dot next, right? So which is basically that 20. Then current next, current next is pointing to previous. So current next is pointing to previous, means this current next instead of pointing to this is pointing to previous, which is basically null. Okay, so this is basically breaking the link and pointing it. Give me a minute. Okay, so this is just breaking the link and pointing it to this one, the second line, line number 35. Now previous becomes current. Okay, so previous becomes current, which is basically our 10. Okay, and the current becomes the forward. So current becomes the forward. So current becoming the forward, which is this one. So now C again becomes the forward, which is basically 20. Okay, so this is the current scenario right now. Now forward equals to current dot next again. Okay, so forward equals to current dot next again. So forward equals to current dot next. Now current is basically 20 and the forward will be becoming 30. Okay, and current dot next will point to forward. Now current is this one. Okay, so you see this 20 is current over here. Current next is pointing to previous. Now current next will point to previous, which is basically the 10. So which is basically the 10. So you break this link and you then make this link. Okay, so current dot next equals to previous. Okay, and previous equals to current, so previous becomes the current again. So previous is equals to current, which is basically 20. Now this link is something like this. Okay, so 20 is here. Okay, and 10 is 10. Instead of pointing to this is something like this. Okay, so currently this is the scenario. Okay, and this is 10 is pointing to null. Previous is equals to current, which is 20, and current again becomes forward. So current again becomes forward. So forward is basically our 30. Okay, and the count plus plus is happening at the end step when count is less than k. Now we have reached this point, right? So if the count is less than k, so let's say it is 3. If I want to have the count as 3, so one happened. Okay, one part happened, second part happened, now third part is going to happen, right? So 1 2, so 2 is less than 3, again this will happen. So forward equals to current dot next. So forward equals to current dot next, something would be there. Currently it is null, so forward we do not have anything in forward, so forward equals to null for now. Okay, then current dot next previous. So current is this, and next previous. So current is 30 and 30 next to previous. It means that again breaking this link and doing something like this, right? So current next is making to previous, this line, line number 36, right? Then previous equals to current again, so previous becomes the current again, and this way, so previous is equals to current again. Okay, and current becomes the forward, which is basically the null. Okay, current is basically the null, and the count is increased. If we carefully look at the link, like the list we are having over here. Okay, so if you currently have a look at this, so we're done, right? We are done. Okay, so reversal has been completed. Now, if forward not equals to null, but yeah, obviously the forward has reached to the end, then you will just return the previous. So what is the previous exactly? Previous is 30, so 30 should be returned, right? So you are returning the previous over here. So this is the recursive, this is the iterative way of reversing a linked list, right? Having 3 pointers: previous, current, and next. Okay, so forward will keep the forward pointer, take care of the forward. Current dot next will just point to previous, which was the previous node. Okay, the previous becomes current, current becomes the forward, and that is it. So this part is our loop way to reverse the logic. Guys, is this part clear? Is this while loop clear? Or should I repeat again? Okay, guys, are you there? So is that part clear? Okay. So we had a recursive solution. This is an iterative solution. Okay. Now list. So if you have three here, three nodes here, and you have to do k reverse. K reverse means reverse three at a time. Okay. So this linked list would be 30, 20, 10. Okay. So you are reversing just three nodes at a time. So it should be 30, 20. Okay. 10. Then so it would be 60, 50, 40. So 60, 50, then 40. Okay. And then we have just 80 and 70. Okay. So this loop will reverse it. Okay. And if forward is not equals to null, now forward is current dot next, it means that if your list is only three elements, it is fine. But if you have one more element, which is the case, okay, we have one more element, we have lots of element over here. Now the forward will be at 40. Okay, since forward was nothing, so we put it null, right? Then current was null and this loop broke. But if we had something in the like forward, so forward must not be null or current must not be null. Although the count would become 3, so this loop would break anyway, right? But if you check line number 42, what it says, you will call this a reverse helper again if forward is not null. If it means that till your linked list is not empty, you will keep calling this function. Okay, you will keep calling this function. Now head dot next, you will append this to head dot next. Now head is a pointer to, if you see here, current is equals to head. It means that current always points. So head is this one, right? Head is 10. Even though the pointers are changed, the head is again pointing to 10 itself. Okay, the position of head is not changed. Now, if you have to append the reverse list, if you have to append the reversed list, the next reverse list, which is basically 60, 50. Okay, so 60, 50, and then 40. Okay, so this is the again k reverse. So why it is written head dot next? Because we have to append this after 10, right? We do not have to append it after 30. You have to append this after 10, right? So you'll just cut this something like this, and you will append it after 10. Okay, so 60 would be appended over here. Okay, then then you will have 50. Okay, then you'll have 50, and then you'll have 40, something like this, right? So 10, 20, 10, 20, 30. Okay, so at 10, then okay, so 60, 50, and 40. Okay, so 60, 50, and 40. So after 10, 60, 50, and 40. So this is what it is happening. So this method is taking care of um, like, okay, calling the function again, right? If you do not have something, so you just return the previous is basically the uh, last node, okay, after reversal. So this is what the, like, if we have k equals to 3, so we can check if you are getting the solution, then we can check for 2, 3, 4, any other solutions also. Okay, so you can see that 30, 20, 10, 60, 50, 40, and 80, 70. Okay, so we are getting this. Now, let's check for 2. Okay, so what if we have to do 2 reversal means 20, 10, 40, 30, 60, 50, and 80, 70. Okay, so this should be the solution. Let's see if that is working on this one also. Okay, so 20, 10, 40, 30, 60, 50, and 80, 70. So this is one more k reverse solution. Okay, so in here, the only changes, instead of going with the recursive approach, we are going with the iterative approach of reversal. Okay, so I guess linked list problems are easy. So that like, the only things we need to take care of is the, like, how are we breaking the link and how are we making the link. Okay, so while you break a link, like point something to null or some part, okay, and then you create a new node and like put your next to that new node, something like something that sort of. So you have to take care that how the nodes are behaving, right? So that is what you need to take care in linked list. Okay, and this part I guess is easy. So iteration and recursion. Okay, try to solve the question, complete it. If you have already started, good. If you have already done, that's very good. If you are yet to do linked list, please go on. If you need help, try to ping. Okay, we'll solve that question. And yeah, that is it. So this was all for linked list, right? So let's proceed and pick our next topic, which is in kind of we have already discussed, okay, while we were discussing about recursion, that is stack. Okay, so it's a famous data structure, and we'll see how a stack work, what's the idea behind stack, what are the concepts and all those sort of things. Okay, so let's see, and we do also have a separate library for that. Okay, stack stl is there, standard template library is there, and we'll use that also. So let me clear this. So this is official documentation, okay, provided to us by Oracle. You can just read about it. Okay, so stack class represents last in first out a stack of object. Okay, so last in first out example can be, so what it can be example of real world example of last in first out? Correct, correct. So stack of box can be one example. Very correct. Okay, it says that the usual push pop operation are provided. Push pop means pushing means obviously adding it, popping means deleting it, as well as a method to peek at the top. So peek is method to check what is the top item of the stack. A method to test for whether a stack is empty. So we'll have a empty method, a method to search from the stack for an item, discover how far it is from the top, and yes. So we have this. A more complete and consistent set of LIFO stack operation is provided by the DQ interface implementation, which should be used in preference to, okay. So you can just check it out. The details. So we have the constructor. Okay, so constructor, we can check the method also. How do we create one? Because everything is like already present, so you can just check things out. Okay, so public stack, create a empty stack. Okay, do we need to provide? Um, okay, so do we need to provide the generics, or it would work anyways? Okay, we'll check it out, and let's check the method of stack, and then we can proceed. So do we need okay, so we are using generics anyways. Okay, that's totally fine. So we can implement our own stack using linked list, right? So you can have a stack using linked list. So the point is we have to keep this LIFO principle alive. Okay, so LIFO principle, whenever you're like whenever our data structure is following this LIFO principle, all is well and good. Now, uh, so a stack, okay. So in recursion, what which kind of a stack do we have in recursion? What do you call that a stack? Yes, yes. So it is called function call stack. Okay. Now that is also last in first out. That is how recursion work, right? So you go at the end and then keep on returning your whatever the things you want to return. Okay, whatever the solution you want to return. Similarly, like pushing means like and following the LIFO principle. So pushing means 10 is post, 20 is post. Okay, 30, 40, 50. Okay, so you're pushing something like this. Whatever is pushed at the last is popped out first, then this, then this, then this, and then this. Now, how can you use linked list to do that? How can you use the linked list to do that? So you can create a linked list with a single node. Okay, but here's a caution: if you put your if you put your um, node at the end of the next node, okay, so at the end of the next node, you have to traverse a way back and then you have to pop it. Instead, if you are using linked list to implement a stack, what you can do is, any ideas? Okay, instead of adding new node next of the current node, make the current node as the next and change your head. So this was the previous head. Cut this. This is your new head. Create a new node. Okay, this is your new head. Okay, now if you have to pop it, this is very easy, right? So popping in linked list is very easy. How it is easy? You can simply say that head is equals to head dot next. That is it. So cut this head. Now head becomes this. Okay. So this nodes become unreachable, garbage collected. This is popped out. So you have this. Okay. Head equals to head now. Head dot next. Right. So you reach here. So you can use the linked list to create a stack. So I guess this is a question also in the lecture. Okay. So you can just create something like this. Okay. So already are having all, so we can already access stack over here. It is a part of java.util package. So they have already implemented it, sorry, they have already imported it. So you can say a stack integer. Okay. Okay, so you can say a stack integer st. Okay, and you can have new stack. Okay, something like that. Let's try the basic operations. Okay, then we can proceed forward. So having a stack now, um, you can stack dot push into it. Okay, so let's try to push it. So stat st dot push st dot push 20. Okay, let's put 30. Again st dot push 50 and st dot pop. Let's do some operations and then we'll check it out what's happening. So st dot pop. Okay, st dot stack dot push 80, stack dot push 90. Okay, stack dot. Okay, the question, guys, what should be printed? What should be printed at the end after line number 25? What should be printed? Okay, so I want to print the complete stack. Okay, so what should be printed? 80 and 10. Okay, so 80. So this, okay, let's see what is happening. Basically, we push 10, then 30, then 50. Okay, so the stack is something like, okay, so we can write it here also. So a stack would be something like um, 10, then 30, okay, then 50. So this is the topmost one, right? So which is to be popped. Now we are popping 50, first pop, second pop, we are left with 10, okay, then we are again pushing 80, then we are again pushing 90, okay, and that is a final pop, and we are popped with this, okay. So these two methods will be adding and deleting, okay. Then we have a method which is empty, okay. So empty method tells if the stack has some elements or not, okay. So I guess it's a boolean, okay. Okay, we'll check the doc. So this is what it is, and in order to print it, we can basically do st.pop. So st.pop returns the element itself, okay. So if it is not empty, let's check it out. if you have written the methods correctly. So it says that cannot find the simple empty. Okay, so what's the name? What is the name? So is empty is the function? Okay, so is it a property or method? Let me check. So if it is a property or method. Okay, so it is so empty is a method. Okay, and this pop method return type of pop method is, guys, what we are getting in pop method. What's the return type? Correct, very correct. So whatever be the type introduced, that is what it is returned over here. Okay, so push method does not return anything, that is to be void. This is boolean. Okay, that is it. So we already have a stack in the inbuilt in the STL, so we do not have to struggle that much. We don't have like linked list is also easy, so just you can create your own stack. That is not such a big deal over here. Okay, you can use I can use array, you can use dynamic array, you can use linked list to build this kind of data structure. Okay, let's do some problems. And do we have any questions over here? So okay, this one is easy. Okay, so last in first, or do we already know this? Okay, so this one is easy, nothing to discuss over here. Correct statement. Okay, so not the correct statement. So it says what is not correct. So stack data can be implemented using linked list. Yes or no? Yes, right. Okay. New node can be only added at the top of a stack, right? Okay. It says new node can be added. No, this is wrong and this is wrong. Okay. Okay. What else with the stack implementation? It says which of the following operation takes worst case linear time order of n in the array implementation of a stack? Okay. Here's the point. Tell me, how can we implement things in, like, implement a stack using array? How can we do that? Any ideas? Using array? Okay. Okay. So let's talk some more things. So push takes order of using the stack inbuilt package. Push is taking order of one, right? You just have to take care of the like top, right? You do not have to traverse. Pop is taking order of, correct, popping from the top, no need of traversal. Okay, empty and all sort of things are taking. So empty also. So if you have something at the top, okay, that is it. That is it. Then we have something called as peak, stack dot peak, to peak at the top. It is also order of one. Okay. Now using the array, using the array, there's one issue. The issue here is you can use the array to build a stack. Okay. First you get 10, all right, 20, all right, 30, all right, 40, all right. Okay. Now how can you pop from array? Is there any method where we can pop from array? Top was this, then top was this, then top was this, finally the top was this. Okay. So if someone asks order of okay, so what is the push? What is the push complexity? Pushing in the array? Push is taking order of one, right? At the end. Okay, so you are taking care of the last index, right? Tail, 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 and order of n. Okay, popping, popping, empty. You can easily you do dot length method, order of one. Again, you can easily peek also. How we can do popping in array? Is there any way to delete empty the cell? You do not have to do that, right? You can just make t equals to t minus 1. That is it, right? So next node will be overriding this. Guys, are you getting the point? Uh, okay, guys. So you're taking care of the last index, right? So you will say that 40 was last element was inserted at index number 3. Now I say you to pop it. So make this index equals to minus 1. So next node will be inserted at I equals to 3. It will be overriding this element. That is it. Popping is of order of 1, right? Just make your index minus 1. Is it clear, guys? Okay. What I'm saying is, okay, so if it is I will just repeat it. So put your element, okay, put your element and tell what so either you store the current index, last index, or you store the like next index. So put so initially it was I equals to 0 where you can put the element. When 0 is filled, make I equals to 1 where you can put your element. You can directly say array of I is equals to element, array of 2, array of 3. Now popping, do array of I minus 1. That is it. So you'll again put at array of 2. So even if there is element, it will just overwrite it. So popping is also order of 1. Okay. And for peeking, you can say array of I, right? Array of I. So wherever is your last index, you can just display that. That's it. Okay. So yeah, that is it. And do you have anything else? Stack implementation. Okay, this we have already done. So what is the sequence of push and pop to get the following? Okay, so what should be okay? So you can just do these kind of questions. Okay, so let's do some code right now. Now here's is one good question we can use. Bracket balanced. Okay, bracket balance. Now how does a program know that our brackets are balanced or not? Okay, so there must be some mechanism, right? So checking mechanism which does the thing. So it is saying that for a given string expression containing only round brackets or parentheses, check if they are balanced or not. Okay, brackets are said to be balanced if bracket which opens last closes first. Okay, so open last and closes first. Since all opening bracket have their corresponding we said balanced. Okay, so do we have any example? Oh yeah, obviously we do have an example. Okay, okay, let's see this is interesting. So bracket bells, guys, all of you are getting the questions first. What is the question? Okay, so you are saying that let's say these are the brackets and you have to find out if these are balanced or not. Okay, question will be if this is balanced or not. So okay, this seems to be balanced, this seems to be balanced. Okay, so here comes the string. Okay, so brackets, and now we have to use a stack. So what type we should use here? Character, right? So that we can store this character. Okay. Now, I have to say either true or either false. Okay, something like this. Okay. Now, okay, I can say that while, or how should I proceed? Any ideas, guys, from your end? How should we check this? If we have balanced brackets or not? Any guesses? Any ideas? Okay, see this. What we can do is we can traverse over the complete string. Okay, so we can traverse over the complete string. Okay, so I is less than bracket string dot length. Okay. Now, what we can do actually here is, with help of a stack is, so balanced brackets. So balanced. For example, let's say that we have something like this. Okay, something like this, and we want to check if this is balanced or not. So what we can do is we can push the opening brackets into the stack. Okay, so push the opening brackets into the stack. Okay, push it again. Okay, now whenever we encounter a closing bracket, what should we do? Very correct, pop the top element. Okay, again encounter a opening bracket, again push it. Okay, again encounter a closing bracket, again pop it. Again encounter a closing bracket, pop it. Again encounter a closing bracket, pop it. So if the stack is empty, it means that correct, so balance is there. Otherwise, correct. Yes, so that's what we are going to apply here. Now, I will say if the br dot char at, okay, remember the caret method of a string. Okay, so if br dot char at I, okay, the index I, if it is equals small bracket. Okay, what should I write here? C dot push. Okay, okay, or yep, otherwise what should you do? Okay, now at the end of the string, what we have to do? Correct. and just return. Otherwise, okay. So this is the solution. All in all, let's try it out and let's check if we are in the right track. Okay, so we are not in the right track. It says unclosed character literal. Obviously, we cannot have more than one character in single quotes because single quotes represents a single character, not the multiple characters, right? Now it is correct. Let's see if you have any other issues. Okay, it says it's balanced. Okay, so it's because it's balanced. Let's unbalance this. Delete one from here and delete one from here. Okay, let's check it out. So it says it's not balanced. Is it clear, guys? Okay. Now this is how our programs like check for the brackets. So what we are writing in our program, so we are having curly braces opening, curly braces closing, curly braces opening, curly braces closing. So this is how it is checked in the system itself, right? So compiler checks if you miss this bracket, obviously like it will throw like brackets missing or something like that. Okay, so you have your own function to check the balanced bracket. Okay, this is what it is. Okay, what else? Reverse stack. So it says that you have been given two stacks that can store integer as data out of two given stack. One is populated, another is empty. You are required to write a function that reverses the populated stack using the one which is empty. Very interesting question. L- like lots of discussion on this. So how can we do this? The question is reverse the stack using one empty stack. Okay, so let's discuss more about it. Reverse stack. So reverse the stack. Okay, one extra stack. Okay, okay, leave it. Let's do two extra stack. Okay, let's make it easy. Then we'll go with only one extra stack. Okay, so this is your original stack, and you have two extra stack. Okay, this is very easy. I expect answer from you all. Okay, now this is what I have and this is what I want, right? 50, 40, 30, 20 and 10. Okay, so this is what we accept. This is the first helper, this is the second helper. Okay, okay, let's go here again. Now so this is one, and we want to reverse this stack. So tell me, how can we like use these two stacks and achieve this? Uh, okay, okay, little bit of hint for you guys. Pop this, push it here. Pop this, push it here. Pop this, push it here. Okay, pop this, push it here. Pop this and push it here. Now, if you think again putting it here, it will again be the same thing, right? So you cannot do that. Okay, so again push 10, so again 10 will be at last. So what should I do from here now? Guys, this is very easy. Think about this stack. Can I move to this one? Okay, so you can move to 10, we can move to 20, we can move to 30, you can move to 40, and finally you can move to 50. Now what's the next step? Correct? Yes, correct. So you can just keep on popping and pushing in the main stack, so you achieve this. So is the reverse stack with two extra stack clear, guys? Okay. Now let's increase the difficulty. One extra stack. Okay. The question is one extra stack. Okay. So you are given one extra stack. Let's think about this. What we can do. So let's make it one easy. Let's make it a bit easier for you. You just have to take care of one extra stack, and you have to solve the problem. It's easy now. Okay. You just have one stack. What to do? We have a stack over here. Okay, we can do the operation with two stacks, right? There is one more stack we can achieve by using some trick. Yes, very correct. We can use help of recursion. Recursion gives a internal stack to us. What can be done, guys? Okay, can I do this? Let's pop 50. Okay, let's pop 50 and let's pop 50. Put everything else in the stack: 40, 30, 20, 10. Okay, so put everything in the stack. Okay, so in the first recursive call, pop this. Okay, put everything in the stack. In the second stack, okay, make the recursive call. Okay, so okay, so passing the two stacks. Okay, not this, not this, obviously not this. What I want to do is I want to have the setup. Okay, we do not have to take care of this one. Do this. Let me raise it again. Okay, not this. Instead, pop this, put it here, pop this, pop this, pop this. Okay, 30, 20. Okay, and pop this and store this. Okay, pop this and store this in a variable. Again, pop this back to this one. So it will become, so what this stack will become, uh, 20, 30, okay, 40 and 50. Okay, you store this 10. Make a recursive call. Okay, so make a recursive call. Now this stack is empty again, right? So make this recursive call with this two stack. So the next call will achieve 20, 30, 40, 50, right? And you have one more stack. Okay, so again move this items. So pop 50. So 50 will be here, 40 will be here, 30 will be here, 20 will be at last. Okay, keep this 20 in this, store it this 20 in a variable, right? Store this 20 in a variable. Make one more recursive call. Okay, and obviously put this back. Make one more recursive call. Store 30 in a variable. Put, okay, so store 30 in a variable. And so if you have 30 over here, so you have 40 and 50 over here. Again, put 14 a variable, and finally 15 a variable. Okay, so when you have 15 a variable, while returning from the stack, while you are returning from the stack, when your stack is empty, push this 50 in the stack. You will return to call 40. Okay, now you are having 15 in your stack. Push this 40 into the stack. Okay, then you will return to 30. Then put 30 into the stack. Again, you will return to 20 in here. So you already have this. Push 20 to the stack. finally you reach at 10, put 10 in the stack. That's it. It's reversed. Guys, is the point clear? Okay, let's see the first step. Let's check for the first step. It will be clear from the first step itself. Okay, 10, 20, 30, 40, 50. Okay, first stack, second stack is step number 1. Push n minus 1 element, not n elements, n minus 1 element to auxiliary stack. Auxiliary stack. Okay, the first operation. Cut. Okay, all are here. 50, 40, 30, 20. N minus 1 elements. Store nth element, nth element in a variable. In a variable. Okay, in a variable. Pop it, store somewhere. Let's say head is equals to 10. Okay, again push back n minus 1 element to original original stack, right? So now again push this back. Okay, so it will be 20, 30, 40, 50, and the last node is in your variable. Guys, is these three steps clear for now? Is this three step clear? Rest will talk later. Is the three step clear? This one, guys, are you with me? So this is just pushing and popping, right? So you have been given two stacks. Okay, what I did, I needed the last node to store in a variable. So I pushed 50, sorry, popped 50, pushed into this, pop 40, push into this, pop 30, push into this, pop 20, push into this, pop 10 is stored in a variable. Do not push into this. Okay. Again, pop back, push it here, pop back, push it here, pop back, push it here, and pop back, push it here. So this becomes empty, and this has 20, 30, 40, 50. So this is what element. So push and minus one elements are there. These are the steps. Store a variable in a element in a variable, and again push and minus one back to the stack. Guys, is the three steps clear? Okay. Let's try to do the code. Okay. It will be more clear for you. So let's do the code. Okay. So not static. Okay. So st dot push 10. Okay. Let's have this 30, 40, and 50. Okay. So 20, 30, 40, and 50. Okay. Again, there is a helper stack given to us. So let's say it stack integer. Okay. Helper. Okay. And new stack. Okay. You have to reverse the stack. So reverse stack. Okay. So reverse stack. And so what should so this reverse stack will take one original stack and one uh, helper stack. Okay, helper stack, and it will reverse our stack. Okay, so public static void. Okay, so reverse stack Okay, stack. Then we have integer. Okay, then stack. Okay, not a question mark. Integer. Okay, and helper. Okay, now if what should be the base case, guys? Correct. So stack empty. Okay, we can return. Okay. Now let's follow the three steps. We'll do nothing. We'll just write these three steps. Okay. So let's write these three steps. Push n minus one to auxiliary stack, store the nth variable, the last variable, and again push n minus one back to the stack again. That is it. Three steps. Okay. So while while stack dot empty is not the case. Okay. So is not the case. Till then, what we have to do is we have to say helper dot push. What should I write here? Stack dot pop, right? Guys, are you getting the point? Okay, but we have we have popped and pushed all the elements. Okay, we do not want to put the last element over here. We want to store in a variable. Okay, so let's pop it from here and store in a variable, right? The nth element. So int last element, last element is equals to helper dot pop, and yep, that is it. Again, so while not helper dot empty, so making this uh, go into the stack again. Okay, so what we did here, guys, what exactly are we doing here? We are storing the last element, store last element in a variable, right? This is what we are doing, right? Indirectly. Guys, is this making sense? Hello. Okay, so indirectly I'm having the last element with me, right? Now finally what I will do is, if this is correct, if this method is correct, it means that my okay. And so this is a bigger stack, so this can be solved. It means that a smaller stack can be solved also. Okay, so let's the recursion take care of this. Okay, let's do the same thing, and let's a recursion take care of rest of things. Okay, so I will ask a recursion to again do the same operation. Okay, now recursion will bring me the reverse stack. How it will do it? It's a recursion tension. We do not have to take care of that. Okay, so it's the tension of recursion how it will do that part. But okay, yes. Now whatever the stacks comes to me, whatever the stacks comes to me. So at the end, I will have an empty stack. Okay, at the end I will be having an empty stack, and I will just push the last element in it. Okay, so I'll just push the last element in it, whatever be the last element. So I will simply say stack dot push. Okay, stack dot push, and the last element, right? That is it. That's it. Okay, let's try to print this. So while not stack dot empty, print ln st dot pop. Okay, that is it. Let's check it out if our stack is reverse or not. So 10, 20, 30, 40, 50, right? So 10 should be coming at the top after this. It says st dot empty is not a function, like not defined. Obviously, it's a function, so we need to make a function call. Okay, one more. Okay, so I'm getting 10, I'm getting 20, I'm getting 30, I'm getting 40, and I'm getting 50. Okay, so what happened? I went to last. Okay, I went to last. At okay, tell me. Okay, leave everything else. Tell me at the last recursive call, at the second last recursive call, which element should is there in my stack? With every recursive call, there are one less elements I'm sending, right? So I'm to have it stored this element, then I will store 20, then I will store 30, then I will store 40. The only thing left at the second last is 50, right? Okay, so if 50 is left, then last element is 50 at line number 23. If this is the only last element I have popped this loop will not run because helper is empty now because there was only element I have popped it, and I'm pushing it back and I'm pushing it back into the stack at line number 33. So 50 was the only remaining stack and I just pushed it here. Then I reached 40. So 40 was the only variable I'm having. So 40 also pushed it. Then I went to 30. 30 also pushed it. Then I went to 20. 20 pushed it. Last, which is getting pushed at the last? See the recursive call, guys. This step is happening after the recursive call is made. It means while returning from recursion, we are adding the element. Remember, we printed the reverse order of a string? That question? Printing a reverse array. Okay, so that is the same thing happening. Okay, I will share the code with you. Okay, you can just try it out. So, guys, how many of you are clear with the solution? If not, you can tell also. All of you are clear with the solution? Okay, that is good. So if you guys are clear with the solution, there is so let's make this problem more easier. Okay, let's make this more easier. You have to solve this question without any extra stack. Okay, can we do that? Can we solve the problem without any stack? Reverse stack without any extra stack. How many of you say that it can also be done? Do not need any stack to do this. Okay, try it out. Okay, and let's discuss in the next session. So reverse stack with no extra stack, no extra stack. Two stack we know, one stack we know, no extra stack. Okay, try this out and let's discuss in the next session. Okay, this these topics are very easy. You do not have to like worry about that. So the only thing you need to take care is recursion. That is it. So I told like previously when we were learning recursion, everything, every topic you see, stack, queues, binary trees are pure recursion. Okay, nothing else than recursion. Hash map is bit okay. DB2, loop and recursion both. Periodic queues again recursion. Graphs complete recursion. Okay, Huffman complete recursion. Okay, and yeah, that is it. Okay, so okay, I hope you guys are getting some, like, getting the ideas, and I really hope you guys are solving the questions. Okay, and if you are stuck somewhere, please reach out even in the weekdays. Okay, we'll try to solve your problems, and okay, so we'll try to finish this part. So, is the WebD lectures unlocked for you guys? What's the status? From next month. Okay, makes sense. Then we have, I guess, time to like cover. So, okay, obviously it will take like more classes, around 15 classes more for DSA. But okay, anyhow, like the point is, are we progressing or not? So, I hope you guys are getting things. Okay, and if you have any doubt, if you have any feedback, anything, like anything you want to say, like any good feedback or bad, like there's no bad feedback. If you want to have some improvement, please tell. Okay, should I add more content, or should I go slow or go fast, or whatever it is? Okay, okay, please mark your attendance in the sheet, and let's meet in the next week. Okay, okay guys, bye.